I'll start the stream here. So yes, hopefully everyone got my note on Tuesday. Just for future reference, if we have more of these days where it's too dangerous to be outside and the public schools are closed, odds are good I'm going to cancel class. I live in Coralville, and if it's not safe for me to come, it's not safe for you to come, and there's nothing I have to say that is so important that it can't wait 2 days. That's what I figure. So use the time to catch up on your readings or the rest of your life as you see fit. If we have too many snow days or cold days as it stands, I may start recording lectures offline for you to view or something like that, but just whenever weather is bad, please check your email in the morning. That way you can see whether or not you need to come in. So thank you for coming back. We're continuing our Making Friends with SAS journey here. We're still going to use the same materials that we downloaded last time, so pull those up if you haven't done so already. Let me get projecting here. Open up your virtual machine SAS if you haven't already done so. We'll do a little bit of review and then we'll do some new stuff. Okay, let's see here. There. That works. Let me see if I can get the lights a little bit better. There, does that look better? Is that easier? Okay. Good deal. So, I wanted to point out to you the homework assignment that goes along with this. The idea of this is that everything that you need to do this is inside that example SAS file. You should not need to refer to anything outside of that. Your job is to find where the information is and make your own version. So really, it's the idea of find and replace. I've given you examples of all the various types of commands. Your job is to figure out which aspects of the code that you will need to replace. So I have 2 data sets inside the folder here, one that's saved as an SPSS format, and one that's saved as an old-fashioned Excel, so the .xls extension. They're from a fictitious longitudinal study where we're having dyads, husbands and wives of the same pair, and you'll have to do various tasks to get them together. So you'll need to define a SAS library and a macro variable, so we'll review that. Merging them, sorting them. So the idea is that the wife and the husband data should be on the same row, so it's an add columns kind of merge. And then we get to the point here where we are stacking. So we've had questions about that. I haven't talked about that yet. So that's what we get to do today. So here is the file that we were working with before. Does everybody have this up? Okay, great. Do you have your line numbers on the side here? That will help us follow along. If you need to reinstate them, you should be able to go to the Tools menu and then Options, and it's either Enhanced Editor or Preferences. I can never remember which. Oh, it's Enhanced Editor. There is a little box showing line numbers. Make sure that's checked, and that way we can refer to the same section of code. If you've been taking notes, your sections will be off a little bit, but it should be reasonably close. So the way that you can take notes here, the very first thing at the top of this file are examples of how to write comments. Comments show up in green. They're things that you can write notes to yourself and SAS will not process them. So they begin with an asterisk and they end with a semicolon. If you want to comment multiple lines at the same time, here's how to do that. It's a slash and a star to begin the comment, right, and then a star and a slash to end it. So hopefully everything that I'm saying is already written down, but if you want to take notes, of course, that is a helpful thing to do. Leave yourself a trail of breadcrumbs. When I'm writing SAS code, initially you're taking notes in terms of this is how I import this data, or this is how I do whatever. later on, as you get more familiar with the terms, it's a good idea to switch your comments to also describe the motivation. So for instance, I'm sorting this data set so that I can merge it later, or something like that. That way, when you look at your code a year from now, 2 years from now, you will leave yourself a trail of breadcrumbs to know what you were doing in each step and why. That way it all fits together. So I'm in the editor window. This is the .sas file. It's just a text file. That means you can open it and write in it in any text editor, not just SAS proper. The first thing that we learned how to do last time was to tell SAS where our stuff is. There are 2 distinct ways to do this based on what kind of stuff you're referring to. The first thing here, these libname statements, is what you use if you have existing SAS data sets. So if you want to import existing data sets to work with them, to manipulate them, or to analyze them, or if you want to export into a SAS format. The libname statement allows you to refer to a place with a shorthand, that way you don't have to type that place over and over again. So for example, option 2 here is what it will look like if you're using the SAS virtual machine. Libname is the SAS statement. Note that it's in blue because it's a SAS command. SAS path is what I called it. That's my name. You can write any name you want so long as it's 8 characters or less. And then inside quotes is the path to the location. So the virtual desktop part is this // client, and then from there it would be wherever it is on your hard drive that you're pointing to. So you end with the folder location, not files, but the folder. And anything in this pinky purple color, do you remember the special rules for this? Case and space sensitive. So last time, for instance, I tried to run this code and I found an error because I forgot an underscore. So if you get an error when you run this, check your path. Make sure that it is exactly correct. One easy way to do that is to use an Explorer function. So in Windows, for instance, there's this bar at the top. If you're using Macs, I'm guessing that there's something similar. If you put your cursor up in the bar, it translates into a path that you can copy and paste exactly. So that'll save you some typing. So I'm going to run this to get us started. Do you remember the keyboard shortcut to execute code? F3. Yeah. Alternatively, here's the little running man at the top that you can mouse over very carefully, because next to the running man is the delete key for reasons that I still will never understand. The log at the bottom here is where you will always go to make sure that whatever you did executed correctly. Black and blue is good, red is bad. If you ever see red, it's angry with you about something. It didn't work. Occasionally, error messages will show up in blue as well, but those are the ones that are less insidious. So once you have executed that libname statement, you should get a message like this. It says, libname SAS path was successfully assigned as follows. Hooray. Then we talked about data steps, the 3-piece set of code that you use to do manipulations to existing SAS data sets. Just to review here, when you see data by itself, that says make me a new data set. After data comes the name of the data set, which has 2 parts. The first part before the period is the location, the library, where work is a default temporary location. That's where I always do manipulations to files. After the dot is the name of the file. The set means from. The first part, then the library, SAS path. The second part, the name. And then finally, run makes it go. And as the analogy I gave you last time, it's the please at the end of the sentence. So this is the fancy way of saying basically say that. You're starting with an existing file named on the set statement. You're making a copy of it in the work temporary directory so that your original file stays unmodified. So we practiced that. Exporting then works exactly backwards. If you want to save it to a permanent location, the lib name of the place you want to save it to goes on the data set. And then where it's coming from, the work directory goes on set. Usually you don't need to save SAS datasets, you only need to save the code, because then you can rerun the code and recreate the data as needed, but that's just in case. So, questions so far? All right, so assuming that you want to use the same shortcut technique to refer to any kind of file, not just a SAS file, we have to do it differently. Same idea, different code. So this is on line 102 of my folder here. It's the statement that begins with let. So when you see code that has a %sign, that is a program command. It's a syntax command. So it's not doing something to a data set, it's doing something to your syntax file. And in this case, what it's doing is creating a new syntax variable called elsepath. It's an abbreviation. The definition of the abbreviation follows the equal sign. So then everywhere in the code below that it sees a reference to elsepath, it's going to find and replace with this path. That way you don't have to type the path 8 million times. If you want to change where your files are, you change it once when you define elsepath, and it automatically updates everywhere else. So we looked at examples using this for importing other kinds of files, such as you'll need to do in your homework. Proc import is the generic version of this. Data file equals, and so this is an example writing out the full path. The analogous code, the exact same thing, using the abbreviation instead, is down here. So here's the else path that we defined up above. To refer to it, to make SAS say, okay, now read this and go find and replace, it's ampersand, that's the special character above the 7, else path, and then the dot. So these two sections of code here do the same thing. Note that the first part of this is the path. I still have to tell it which file within that location I want to import. So you have the name of the file and the extension. Out says, okay, I'm going to take that file now. What do you want me to do with it? I'd like you to make a new SAS file out of it, put it in my work temporary directory, name it whatever after the dot, and then the DBMS, Database Management System, is what that stands for, tells it what kind of file it used to be. That way it can read it correctly. SPSS files have a particular problem that they have value labels that are used instead of the digits when you're doing analyses. So to circumvent that, here's an example where we take a format statement to get rid of those. Scrolling down here, to get data out into another format, it's proc export. It looks basically the same except for the names of the commands are slightly switched up. Data equals meaning what's the existing data file that we're going to export. Out file means where is it going to go. And then DBMS again, what kind of file format would you like it to be? So here's what it would look like for Stata. Stata data files have a DTA extension, and so the DBMS would be DTA for those. And there's a whole bunch of different proc import options for different kinds of data. Excel was the other one, so this is the other example that you'll use in your homework assignment. It works the same. The only catch is that because Excel workbooks have multiple sheets, if it has more than one sheet, you have to tell it which one you want. So we have sheet equals as an additional command. Note that it's in quotes, pinky purple, case and space sensitive, so get the name of the sheet exactly right. The get names option here is used whenever you have an Excel file where the variable names are the first row. That way you don't have to type them. It recognizes them as names in that case. If the names don't obey conventional naming characteristics, like if you have spaces or special characters, it switches those to underscores and tells you about that in the log. Export works the same. Here's another example with CSV, comma-separated value files, text files, and so on. Sorting, we looked at that last time. Fairly self-explanatory. You list the variables that you want to sort on this by statement. And then merging, I think, was about where we left off. So this is something that you will use in your homework as well. It's good practice to sort by the variable that you're going to merge on, even if you don't technically need to. Sometimes if you're merging rows, you don't need to sort first, but if you're merging columns, you will. One catch, just to warn you in your homework, I deliberately tried to screw with you to mimic what you will find when you're working with real data. Both data sets to be merged here have to have the exact same ID variables. So when you first try to do this, you will likely encounter an error until you verify that this is true. Hint, hint. SAS does not care about capitalization in the names of variables, though. It is not case sensitive. When I write SAS code to help you out, anything that is a dedicated SAS command, I write in capital letters. Anything that is an option, like the name of a data set or the name of a data variable that you have to change, I write in either title case or lowercase. So ID variable, if it's capital ID, is the same as lowercase ID in terms of SAS. That is not the case in other programming languages. Keep and drop, those do the opposite. Keep is how you take a file and only keep certain things. If you only want to save a few variables, it's more efficient to use keep. On the other hand, if you only want to drop a few variables, it's more efficient to use drop. If it's not listed on either of these statements, it stays in. Retain is used to reorder. And then here's some instances using where to subset data to certain rows that meet certain characteristics, such as gender equals 1, group equals 1, or complete cases. And I believe that is about where we left off. We looked at this saving SAS output as Excel files or as RTF files, as something that you can take with you. That will be helpful when you're doing homework assignments. That way you can save your output, take it with you, and then sit down and do your homework later if you want to. All right, any questions? Okay. Alrighty then. If you want to create value labels for nominal variables or ordinal variables, here's how you do that. I don't believe this is something that's in your homework or that we readily need, but I wanted to have it here for completeness. Then we get into summarizing data here, so we'll pick up with descriptive statistics. So here is how you start getting information out into output about your data. PROC stands for procedure. Everything is going to be PROC something or another. Freq, can you guess what freq stands for? Frequencies, yeah. So this is how we get frequencies, cross tabulations, and those kinds of things. So in this example here, I say proc freq, what data file am I trying to analyze? Data equals, so note the equals here. That's because this is an option under proc freq as opposed to a standalone make me a new data set command. Table is where you list the variables to be summarized. So for instance, cat_var1 is my way of saying an example categorical variable. So this would give you marginal frequencies if you list it by itself. If you put a star, that's how you ask for crosstabs. So you can put up to, I don't even know how many, but if you wanted a three-way cross-tabulation, you list 3 variables with asterisks joining them. There's other additional options that you can turn on or off in terms of if you want frequencies versus percents and those kinds of things. If you want your categorical variables to use the labels that you defined up above, here's a format statement to show you how that would be done. That way it prints the labels for the values instead of just the values. If you would like to summarize variables by levels of another variable in the data set, such as you want a cross tabulation per group, per sets of rows, this by statement works in any proc to be able to do that. It will spit output out per level of whatever variables you put here. So this can be very handy if you want to generate reports for separate units, for instance. If you have quantitative variables, proc means will give you that kind of information. So here's a couple examples of that. You can ask how many decimal places you want it to go out to if you want to clean up your output. Var instead of table is how you tell it which variables to be summarized. Note the dash here. I'll talk about that in, I think, a section that's coming up, but this is an abbreviation. Where did it go? Right here. Var1 dash var10. Can you guess what that means? 4, 5, 6, 7. So if you have names that end in numbers, it can interpolate what you mean by that. So that's a handy way to ask for lots of information at the same time. If you want to limit your analysis to certain people in your data set, certain rows, you can add a where command, for instance. If you only want means for certain groups, so you could say where group equals 1 and something else is true, for instance. This is something that you will need to do in your homework. I ask you to print some descriptive statistics. If you want descriptive statistics for combinations of rows, the class statement in here allows you to do that. Class works similarly as by, but the data don't have to be sorted first, and the output is a little bit cleaner. So let's say that I want to find out what the means are of my variables for multiple groups at multiple occasions. Adding this class statement will give me separate output for each unique combination of group and time. Then I can ask, well, how many unique combinations do I want? And that's where the ways comes in. So if the ways statement here is 0 means just give me a pass where I just want the means for all of these variables. 1 means give me the means per group and the means per time. 2 means give me the means per group and per time. So it's how many layers of the cross tabulation do you want this information for? So you only need this ways statement if you're asking for output per level of something such as group here. Otherwise, you can just have var to list the things that you want. Default output is sample size, mean, standard deviation, min and max. You can also ask for a few other things here as options to your proc means. If you want more information than just the basics, proc univariate can give you like everything under the sun. It can give you percentiles, outliers, all that kind of stuff. You can make pictures. So pictures of distributions such as histograms, QQ plots, probability plots, and those kinds of things. I don't need you to know how to do this, but this is just for your reference here. You can also overlay curves for the distribution, such as normal or log normal, if you're looking to compare it to some known distribution. There are a few procs that you need both a run and a quit. They seems like that would be redundant, but it's not. So proc univariate is one of those. There's just a few. Otherwise, it just sort of hangs. Correlations, another piece of useful information that you may want to look at. Proc core for correlation. It will give you both correlation matrices and covariance matrices. That's handy if you need to report a covariance matrix, such as if you're doing a structural equation model or something like that. Here's where you list the variables. You can, again, use a where statement to do it for certain groups if you want to. You can also have the correlation matrix saved as a piece of output here. So let me show you an example of this here. So let's practice this idea. Your turn. We'll say run descriptives and correlations for 5 variables in my SPSS practice data set. So, what are the steps that I have to go through here to be able to do this? We got to work backwards, right? We can't run correlations until we have a SAS data set. We can't import the data until SAS knows where to look for it. So given that it is a non-SAS data set, what do I need to do first to tell SAS where to look for it? I'll give you a hint. I'm typing a percent sign. And the word let. Yeah, that's the else path thing. So let's name it something else besides else path. Let's name it your name today. Here, I'll name it my first name. I'm going to call it Lisa. You call it whatever you'd like. Equals. And at the top here, we should have, from last time, the correct place where your files are saved. So rather than going and get that, I'm going to grab it again. You want the inside of the quotes, the path to where your things are. There we go. I'm double checking my names of everything here. Nope, not that one. So we have 19, longitudinal, then SAS. Yep, I think that's okay. Okay, so note the next little header here that's supposed to be a green comment is black. That's a clue. Semicolon. Yep, semicolon is the end of every command. There. So that will tell SAS where to look for my stuff. Now I need to import it since it's an SPSS file. I gave you an example of that up above as well. So we're looking for proc import. Let's go find one of those. So now I got to change some things. The name of my path today is Lisa. The name of the data set that we're going to practice importing, SPSS practice .sav extension. I'm going to name the imported file the same for my own sanity. So the SAS file it is to become will be in the work library, and I'm going to change the name to be SPSS practice. DBMS equals SAV, and replace means make it again if needed. So that part so far will get us a SAS data set. Now I'm going to copy just the text right above it here to get correlations and to save them. So here is a new option we haven't seen so far, title. That prints a title to your output, so that can help you navigate your output. Anything you type in it is case and space sensitive. So I'll just say our correlations here. Now let's go through the rest of the lines. Proc core, still want that. Data equals. I have the generic here, data file name. What does that need to become? This one right here. Yep. Leave the work in front of it. Now out refers to saving pieces of output. We can leave that name there. Variable refers to the names of the variables. And in my file here, I want the variables to be imported are going to be called GPS1 to GPS5, GPS being the common stem here. So the dash convention here, note that my instructions had a double dash and not a single dash. This is another way of shortcutting names of variables. SAS has two ways of doing that. Single dash is a numeric expander. So 1 to 5 single dash would be 1, 2, 3, 4, 5. Double dash is a positional expander. So it would be GPS1, whatever's next to it, whatever's next to it, whatever's next to it, whatever's next to it, and then ending with GPS5. That way you can ask for a set of variables that don't all necessarily have to be named in a similar way. I don't need to select for any certain groups, so I'm going to get rid of that. And then title 1, when repeated, shuts off the title. Otherwise, every time you run an analysis, this title will keep getting printed and printed and printed, even if it's no longer relevant. So to clear it, you either rename the title to something else, or you can just leave it by itself there. So let's make sure that this worked. So I'm going to run the first two commands here. Let, which means make this variable a representation that you can then refer to, and then proc import, which then refers to it to be able to import the new file. So I'm going to highlight just that chunk, hit F3, check my log, the import dataset has 107 observations and 25 variables. The data was successfully created. Hooray! Now where did it go? Over in the Explorer tab, we got to find the work library if you want to be able to look at it. So we're going to folder up until we get back to the yellow libraries box. Can't see very big here, but it's the first entry under SAS environment. And then work will be the last one. And there's SPSS practice. So we talked about the problem with value labels before. If you're using them as numeric, then SAS understands to use the numbers that underlie them, even if you can't see them. But look at the names up here. So this is a fictitious scale that has items 1, 2, 3, 4, 5, etc. So it is, the stem of the scale is GPS, so here's GPS 1, GPS 2, GPS 3, and then where GPS 4, you would think, has an R in front of it. So this might happen, for instance, if you need to reverse code an item. So if you were to try to write GPS 1 dash GPS 5, it would not be able to understand that GPS 4 needs an R in front of it. But because they're all next to each other, I can use the positional abbreviation dash dash instead, and that means get me GPS 1, whatever's next to it, next to it, next to it, until you hit the ending variable, which is GPS 5. So I'm going to ask for correlations for these. It's a 6-point scale that underlies these responses. One thing, though, whenever you're doing something to data, it can't be open. So you can open the data set and look at it, which I highly advise to make sure that transformations worked correctly, but it can't be open while you're trying to do things to it, otherwise it will yell at you. So I want to right-click on the view table here and close it before I go on. Would you like to see what it looks like if you forget and it yells at you? Okay, I will show you this. Let me see if I can make it mad at me. Well, not the error I was looking for, but import cancel. The data is being used and cannot be replaced. So if it's open, it won't let you do anything to it. Let me try something else here. Data work.spss practice, set work.spss practice, where GPS1 equals 1. So let me just pretend to do something here. Now the data set is open. I'm going to run this command. Oh, it said it was okay. All right. Well, it didn't give me the error I wanted. Isn't it funny how it will never do something to demonstrate unless you're like when you're standing in front of you? Well, it says what it normally says when it's angry with you is member access user control or something like that, and it's in capital red letters. It's very angry. So if you see something that has those words in it, it means your data set is open. So, all right. So data in, we good with that part? All right, so let's get some output. Let's run our title in proc core. There we go. So you now have another window, results viewer. By default, SAS writes HTML output. So you can save it in that format and it will be viewable in any web browser. By default, what you also get in addition to correlations is a table called simple statistics that gives you descriptives. Note that it also includes the label of the variable as well as the names here. So the names show up in this column and labels show up over here. And here is our correlation matrix. It has correlations as well as p-values for significance. If the cells differed in their sample sizes, it would also have n. But let's say that you wanted to report a correlation matrix in a publication. You could copy this table and painstakingly remove each of the p-values. Or, here's the shortcut. That's what this out equals is designed to do, is to output that correlation matrix. It's going to go into the work library as a brand new SAS dataset. So over here on the left-hand pane now, I've got a cores dataset. Let's double click on that and see what it gives you. So it gives the mean, standard deviation, and sample size as the first 3 rows, and then after that is the correlation matrix. So that form then is easily converted into a table that you could then use in a manuscript. To get this data set out, I'll show you the quick and cheaty way, and then I'll show you a more proper way. On the data set in the work library on the left-hand side here, I'm going to right-click. The second option when you right-click here is View Columns. That allows you to look at all of the columns that are in the data set, which can be helpful for large files. But down here, View in Excel. So Excel will open up. It will yell at you because it doesn't understand that it's not a native Excel file, and you can say, yes, it's okay. I'm pretty sure SAS doesn't have any viruses today. And then it opens up as something that you can edit directly. To do that in code so that you're not having to click your way through everything, that's where this right here can be used, this proc export. So proc export, I'll change it to Lisa. It then will give you an Excel workbook that you can name, as well as you can tell it which sheet to send it to. So you can send separate pieces of output to different sheets. That way you have them in an easily editable format. I just figured out why my other error didn't work, because I had an extra S in here. So let me do this again. I'm going to open SPSS practice so you can see what it looks like and try to do something to it. What? No, there. SPSS. There. Try it again. Ah, that is. There, I got it. Okay. You cannot open work.spsspractice.data for output access with member level control. That's the work is in use by you in resource environment data step. That means your file's open. That's what all of that angry red message means. Your data file is open. You must close it before you can do anything to it. All right. Okay. How are we doing? Okay? All right, so transformations to data sets. This is going to look a lot like what you would do in any other program. If it meets some criteria, then do this. So for example, you can use equal sign or not equal. Sorry, these are not aligned. Less than or equal to, greater than, and, or, not, and so forth. Here is the two ways of abbreviating things that I mentioned earlier. So a single dash, like dash var1 dash var50, for instance, that means var1, var2, var3, var4, var5, even if they're not next to each other. Whereas dash dash means var1, whatever's next to it, whatever's next to it, whatever's next to it, until you hit var50. The one thing that people screw up who are new to SAS most frequently is this right here. Okay, do I have your attention? I'll save you pointless, countless hours of banging your head against the SAS. People try to make new variables by typing it in open code, like this, for instance. Go to a new section, new variable equals old variable minus 1, for instance, right? There's nothing wrong with this command, but if they try to run it, it'll say statement is not valid or is used out of proper order. The problem is that this all by itself does not tell us which of the data sets you're trying to do this in. It doesn't know. So the statement itself is correct. It just doesn't know what it's referring to. So anytime you want to do something to a data set, make a new variable through conditional logic or through arithmetic, it has to go inside of a data step. And so it seems redundant. You will see examples from me throughout the semester that have this structure right here. Data, work.datafile, set work.datafile. This means open it up and save it as itself. Then it knows where it's going to go. Any transformations you want to make would then go after those two commands of data and set, and then run. Let's say that you want to make a new data set. You don't trust yourself, so you want to make some new variables and you want to make a new data set at the same time. Do I change data or do I change set? May change data. Data is make me a new data set. Set means from the existing one. If it's the same data set on both, it's just copying over itself. If you want to make a new one, you change the one on data. So if you wanted to make a new variable, it would then go inside before the run after the data in the set. The new variable goes on the left-hand side of an equals. Where it is coming from would go on the right-hand side. So if you wanted to subtract 1 from every value of old var, that's what it would look like. What if I did this? New var equals 1. Can you guess what that would do? It'd make a new column called new var with all ones. So there are more formal examples down here then. All of these steps, though, have to have that data set before them. So these are transformations that happen on the inside of a data step before the run, after the data in the set. So these are things that you will need to do in your homework. Rename. Can you guess what that does? Exactly. So old equals new is the order in which this goes. And you can list as many of those as you want. The only catch is that rename is executed last. If you want to make variable labels, it's the command label, and then the name equals, and then whatever you want the label to be in quotes. It's pinky purple, so the label will be case and space sensitive. Note the form of this statement here, label, and I have one variable, and then I have the next one, and its label, and then a semicolon. So label is one statement. You can list as many as you want, and the semicolon shuts off the end of the statement. Here is another very popular thing to screw up. It looks like it should be okay, but people frequently do this. Okay, wait for it. Do I have your attention? Okay. There. This is the problem right here. Looks okay, right? Label and the label, because everything ends in a semicolon. What happens then is that SAS is going to read this and say, okay, she wants to make a label for old variable 1. Okay, I'll do that. I'm done. This semicolon shuts off the label. So now it comes down here and it says old var 2 equals. Oh, she's making a brand new variable. She's not labeling it, she's making a new one. And she wants to make it equal to this text. So it would make a string variable, a variable that has letters in it, that is equal to this. And if that variable already exists and it's already numeric, you'll get an error message. So make sure that if you're labeling multiple things, you have one label and one semicolon. Alternatively, you could add another label to the front of it. And this is redundant, but correct. Label, close. Label, close. Centering. Do you guys know that term yet? Nope. Centering means changing the scale of a variable, making a new 0 point. We will do this a lot. It matters a whole lot in multi-level models and in longitudinal analysis. So the form of this statement, new variable, so for instance, C underscore to denote that it's the centered version of the predictor, equals predictor minus and then some constant. Typically it is the grand mean or something like it, but it doesn't have to be. And then a label for the new variable. So I will ask you in your homework to center some new variables. This is the code by which to do that. Here's how we take summaries of variables. For instance, if you want to take the mean across several variables, the mean statement, and you want the word of in here. So this is a function. Functions take the form of the command and then the arguments to the function, or the variables that you're supposed to be using, and you can list them separated by commas, or you can use the dash or double dash abbreviation. The reason you need of is so that SAS doesn't get confused when it sees something like this right here. If you forget of, do you know what it's going to do? You write that instead. What you mean to say is, I'd like the mean of variable 1, 2, 3, 4, please. And it's going to say, okay, she wants the mean of variable 1 minus variable 4. It thinks it's arithmetic. The of clues it in that that's an abbreviation for a sequence of variables. Even though it is the same thing in concept, it's not the same thing in execution if you try to take a mean like this. So mean variable equals the sum of the variables divided by the number of variables you summed, right? That should be a mean. The difference, what happens with missing data? When you write out the mean like this, they have to have all 4 values in order for the mean variable to be created. If you use the mean function, it will take the mean of whatever they happen to have. So if that's what you want, to take the mean of whatever data is there, you want the function. Here's some other functions that come in handy. Nmiss or n. This helps you find the number of missing responses or the number of valid responses. We can use those to subset data that are missing. Here's some examples of using conditional logic to find the mean if it meets certain cases. So for instance, let's say that I want to find a new variable that's the mean if they have at least 3 responses, but not if they have fewer than that. So I would say if the number missing of this range of variables is less than or equal to 1, then compute this mean variable. And so there's a then do, else do, dot. Can you guess what dot's going to be? Missing. Yep. So you can set it an explicit instruction. If it doesn't meet this condition, make it missing. And so here's 2 examples using 2 different functions. You can take the mean, you can take the max, you can take the min, you can take the standard deviation, you can take all kinds of things. All kinds of functions. Here's some more down here. Here's a couple other ones that are super handy. The in function allows you to say if it meets a range of criteria. So if you want to be able to say if variable 1 is equal to 2 or 4 or 6 or 8, then do this. Otherwise, you have to write it out. If variable 2 equals 2, or variable 2 equals 4, or it's a shorter way of saying multiple R's. Here's how you would categorize variables if you needed to from a continuous variable. So this is a range using conditional logic. If the variable is missing, then the new variable is missing. Otherwise, else if the variable is less than 1, let's make it missing because I don't want that. Otherwise, it's greater than or equal to 1, but less than 2, it gets to be this, and so on. And then rounding is an easier way to accomplish that. Sometimes we will do this to time to be able to have convenient intervals that are common across subjects. And you will do this in your homework. So the round function does exactly what you would think it does. You name the variable and you name the increment that you want it to round to the nearest of. Here's an example with reverse coding, where you're creating a new variable, starting with missing and then going through every possible other case. Something that I wanted you to see in case it comes up, but not something that I need you to be able to do just yet. This type of reverse coding is very common in social science surveys, where you have certain items that are written with a positive direction and certain items that are written with a negative. And to be able to work with them, they need to go all in the same direction. Well, let's say that you had a 100-item survey and 50 of the items needed to be reverse coded. Do you want to write these lines of code 50 times? Doesn't seem very efficient, right? Instead, you can use what's known as an array. And this is a concept that shows up across languages. And this is what it looks like in SAS. An array is a list. So it's a means to say, you know what, take this chunk of code and do it the same thing to 50 different variables. So if you combine arrays with what's known as a do statement, you can make it execute as many SAS commands as you want. So for instance here, if I need to reverse code 100 variables, I have 2 arrays. The name of the array goes first, how many elements it holds, how many things are in my list, and then the list itself. So in this example, I am taking 100 old variables that already exist in the data set, dash dash. They're next to each other in the data set. And I'm naming that list A old. A stands for array in my name system here. I'm making a brand new list of brand new empty variables. They don't exist yet. Number 1 to number 100. So then I say do, and I need some way of keeping track of how many I'm on, the order of the list. So I'm using I for index. Do 1 to 100 by 1. And then if the old one is dot, then the new one is dot. If the old one is 5, then the new one is 1, and so forth. And so this I in parenthesis here, it's going to start off and say, okay, what? I equals 1. All right, so if A old, I, oh, that means this one, old var 1 is dot, then A new, oh, I'm on the first one, that's new var 1. And the next time through, I equals 1, it's going to go up by 1, okay, I is 2. So if A old I, that's 2, let's go to my list. What's second on my list? Let's pull the second item from this list. Let's pull the second item from that list. I'm sorry? New variable 2, exactly. And so you can have it increment by whatever makes sense. If you have 1 and 2 and 3 and 4, by 1 would make sense. If you only want even numbers, you can have it increment by 2, for instance. And so this is a way then to write one set of code that is executed 100 times. All right. Now, earlier we looked at functions to create summaries of information across columns. So if I have variable 1, 2, 3, 4, 5, and I want to summarize all of the variables in a certain row, that's where I would say I want the mean or the max or the minimum or whatnot. But for longitudinal data, oftentimes we want to summarize across rows rather than across columns. So if you have a data set where a single row is an occasion, so each person has their own set of rows. Here's time 1, here's time 2, here's time 3, here's time 4. What if I want to know the mean observation across time? I can't use a mean function because the data that I want to aggregate across are not columns, they're rows. So I need a mean function that's like across these rows, across these rows, across these rows, across these rows. Proc means can do that for you. And this is a very common thing that we need to be able to do for longitudinal models and multi-level models, so I wanted to show it to you. So it works with 2 steps here. First is sorting the data set by whatever variable identifies the rows that are to be held together. So for instance, if I have an ID variable that keeps track of which person is which, proc sort by that ID. Then we have proc means, because means allow us to take means, standard deviations, min, maxes, whatever. But here's the trick, by ID. So it's going to collapse a summary data set across the rows where it's like ID1's rows gets 1 new line, ID2's rows gets 1 new line. And it's going to make a new data set that is a person level data set where it's 1 row per unique value of ID. The new data set then I'm calling summary file, and then you can ask for whatever types of summaries. So for instance, if I want the mean of variable 1 and variable 2, in my new summary data set, I can name it something different so that I understand that it's a summary of variable 1, such as var1 mean and var2 mean. You can get the standard deviation across rows and name it that. You can get the number there, the sample size. So this is something that we will use in class a lot to get person-level summary information out of longitudinal data if you don't have it already. To then take that person-level summary and merge it back into the original data, we saw merge earlier, but the order of operations here is critical. Talked about this at the end of class the last time, but we'll go back over it. So first off, data, make me a new data set. The name on here is the original longitudinal data that I would be working with. So the merge statement starts with the data where it's one row per occasion per person. So let's say if there's 4 occasions in the study, each person has 4 rows. The second file is the new summary one we created where each person has 1 row because it's their mean across occasions of their variables or their standard deviation. So when summary file gets merged in, it's going to take that person's single row of data and copy it down through all of their occasions, and that's what we want. If the order is reversed, it won't work right. So the bigger file, the one that has more information is first. The summary file with less information goes second. Last but not least, the thing that you asked me about when you came today. You've been waiting for this, right? All right. Stacking. Depending on who your data manager is, oftentimes longitudinal data are stored a different way. They are stored in what is known as a person level file, where you would have like time 1 to time 4 as headers, and then we would have like, IV time 1 to time 4, dependent variable time 1 to time 4, dependent variable time 1 to time 4 as separate columns. To do longitudinal analysis though, we need it to be in the format in which we have 1 row per occasion per person. So I have in the folder here, come on, you can do it. My computer is frozen up, but I have examples of each type of data set in the folder of files that were downloaded for today. I don't know why it's not working. Come on, there you go. I knew you could do it. There. So I'm going to open up, let's see, what is it called? An SPSS file. Oh, I have to open it inside there. That's not going to work. Why is it frozen? Apparently my computer has lost its will to live. Come on, you can do it. You can do it. That's okay. I can talk. The idea, I'm going to draw on this. I'm like afraid that I'm going to draw on something in permanent marker. I've actually done that before. The maintenance people were not pleased with me. But it doesn't look like I have markers, so I'll have to just gesture. Okay, so the idea is that we're going from a file where it's 1 row per person to a file where it's 1 row per occasion per person. So if I have like time 1, time 2, time 3, time 4 saved as 4 different variables in a row, it's like I want to take that row and transpose it per person. Like that. It's a per person transpose, where I take the information that was stored across columns and I convert it into 1 row. Come back! I really don't know why my laptop is angry with me, but it's not responding to anything. Come on. Let's see, Control-Alt-Delete, Task Manager. Let's see, where is my SAS file? There it is. I think it's the virtual machine that's angry with me. So we're just going to open it with Notepad. There. There. Can you all see the code still? All right. Let me find this and open it up in Word so that we can actually see it. There. I can work around this. It just won't be as pretty. There. Okay. So I'm looking at code then that would have been in my SAS here to import data in which it's one row per person and the variables are saved in separate columns. So in this file, I have two sets of variables. One is called DV, stands for dependent variable, time 1 to 4, and the other one is the age that they were at each occasion. So I have age time 1 to age time 4. So 8 variables per person. What I want to do is take it so that each set, so times 1 to 4, that was in 4 columns, instead forms 4 rows in 1 column. So transpose like that. Does that make sense? Okay. In the file, you can open them using SPSS. There's an example that's called multiv-prac and stacked-prac. That's the before and after that go with this example in the code. So here's what it will look like to solve the problem. First data, make me a new data set. I'm renaming it though because it's data set with a different structure. We're going from 1 row per person to 1 row per occasion per person. Set from the old file, and then I have to tell it what information goes together on the same row, where a row is an occasion. So all variables, we're going to start with time 1 that pertain to time 1 are going to be referred to here. So first off, I'm going to make a new variable called wave. That means which occasion it was, ordinally speaking. So a new variable goes on the left-hand side of the equals, wave equals 1, semicolon. That's going to make me a new variable called wave. dv is another new variable. The first time through, I'm going to populate it with whatever the variable was at time 1. The second time through, you'll see that switches to whatever it was at time 2. So it selectively takes information from one column. Column 1 puts it in row 1. Column 2 puts it in row 2. Column 3 puts it in row 3. All in the same DV column. So the left-hand side is the new variable in the stacked data set. The right-hand side is the old variable that it is selectively pulling from. Going to do the same thing for age. One new column called age. First time through, it's pulling from column 1 into row 1. Next time through, it's pulling from column 2 into row 2. And so on to time 4. Then finally, to make it stop and go to a new line of data is this command called output that ends in a semicolon. That writes a new line of data. All of the rest of the information that was originally in the file is just going to get pasted down. So when this is all said and done, I will have 4 rows of data per person to go with my 4 occasions. What would happen if I had 5 occasions? Can you guess? Another one of these, right? If I had another variable, let's say I also collected their stress level at each occasion. It would go inside each of these here. I'd have stress equals stress at time 1, stress equals stress at time 2, and so forth. So all the variables that went with time 1 go on one command before the output. All the variables that went with time 2 go on the second.
So there are 6 new variables in the homework, so should I put like 6 variables?
Yeah, so if there's 6 variables in the homework, which that sounds correct. Let me get the names of those here at the top. Yep. So there's the husband's versions of 3 variables and the wife's versions. That means you're making 6 new variables. Where here'd be 1, here's 2, 3, 4, 5, 6. All before the output. Now that's a lot of typing, right? Who likes lots of typing? Nobody! So here's a shortcut using arrays. Same idea, but we're going to make SAS write all of the lines for each individual occasion. So data and set are the same. Next is a separate array, a separate list for each of the variables to be transposed. So in this example, I have 2. You guys will have 6. So you need 6 arrays. Then, because I want to do the same thing for all 4 occasions, I can say do wave equals 1 to 4 by 1. And I only need to write one statement, and it's going to make a copy of it 4 times. So wave is the new variable that's being created to keep track of which row I'm on. That's going to show up in the data set. Here's dv is my second new variable, and it's going to pull from this list, adv. So here's my list, and it's going to pull whichever sequence in the list I'm on as given by wave. So the first time through, wave is 1, it's going to pull dv time 1. Next time 2, wave is 2, it pulls the next one, dv time 2. Here's the second variable, same setup, but now referring to the second list. So what if, just as an example here, I had 100 occasions, not 4? So if I was doing it the long way, I would need 100 of these, or what do I need to change? I need that to 100. Anything else? Yeah, everywhere there's a 4, you need 100. And yes, there are actually more advanced techniques where you can get it to tell you how many you have, but we'll just do this for right now. Control H is find and replace. That will be your friend. So given that there's 6 variables to be transposed, you need 6 lists. Do 1 to however many is however many occasions that you have. The last piece here is that I'm asking you to drop the original variables. So I've given you 2 examples of how to do that. After we take the columns and turn them into rows, we don't need those columns anymore. So you can either have a drop statement where you list each set of variables, like this, or if you know that all the variables to be dropped are next to each other, dash dash. Starting with this one, whatever's next to the end. So these are equivalent because of the position of the variables in the data set. Then the rest of this we went over today.
And what about the second index?
Ah, yes. So in the instructions, I note that we have time 1, 2, 3, 4, but the times are not equal interval. Time 1 is basically like time 0, like there's 0 occasions into the study. Time 2 was after 6 months, time 3 was after 18 months, and time 4 was after 36 months. So I can't do an analysis with time 1, 2, 3, 4 because the distance in time is not equal. A slope for that variable doesn't make any sense. So it's helpful to have something like occasion or wave that just keeps track of 1, 2, 3, 4 just for sort of data management things. But an analysis variable needs to know exactly how long it's happened. So after you stack it or during, your choice. There's 2 ways to go about this. In the stacking syntax, you would do something like this, time in study equals 0, right? The second occasion, time in study was 6 months later, right? So you can fill it in here, 18 and so forth. Alternatively, you could just do wave, like we had it, and then after this step, write another statement that says, if wave is 1, my new variable is 0. If wave is 2, my new variable is 6 months. If wave is 3, like that, your choice. But then we would use the new variable in analyses. The 1, 2, 3, 4 variable, the ordinal version, would just be like an ID variable instead.
So you still want us to keep the unit as months instead of years?
I told you to use years. So yes. Just a touch of arithmetic, not much though. And are any of you in Jonathan's class? Yeah, you get to do this in R. Your homework, it's the exact same thing, except that he has different instructions for how long it's been in between occasions. The backstory is that I've given this assignment for so many years in a row to catch cheaters. Each year, I change how long it's been, and then I know if they have the distance I gave out last year that they stole their homework from someone else. So so his version has different numbers here, but yeah, he borrowed my homework. So you'll get a chance to do this in R, and then you can do it in SAS. And if you want to do it in another program, knock yourself out, right? Who am I to prevent you from doing that? But so yeah. But I said I wanted it in years in this case, so convert months to years. All right, so that's it. Sorry, we went a little bit over due to technical difficulties. Questions? All right, so this is due a week from Friday. Remember, if you get stuck and you're staring at something for more than 15 minutes, stop and email me. I will help you. Deal? All right, so office hours then. I'm just going to hang out here, and you're welcome to stay and work on this. If nobody's here, I'm going to go back to my office. So if you ever come back for office hours and I'm not here, check my office upstairs, because I'm not going to hang out down here if no one wants to visit. So, all right, then I will see you Tuesday.